When wiring a detached stable located 300 feet from the main house, it can be treated as a main service, which the National Electrical Code, or NEC, permits for long runs where a separate service panel is installed. This approach involves specific grounding and bonding requirements to ensure safety and compliance. Grounding is crucial, and at the stable, the neutral and equipment grounds must be bonded together, which is a requirement for any detached building with its own electrical service. The NEC mandates a grounding system consisting of at least 2 ground rods, each a minimum of 8 feet long. These rods must be driven at least 6 feet into the earth and spaced at least 6 feet apart to provide effective grounding. For the electrical setup, installing number 3 conductors is suitable for a 300-foot run to minimize voltage drop, ensuring that the stable receives adequate power without significant loss over the distance. Schedule 80 polyvinyl chloride, or PVC conduit is appropriate for burying the wiring underground, providing physical protection and preventing corrosion. Installing a hand pull during the installation process will allow for easier pulling of new wires in the future should modifications or upgrades be necessary. The circuit breaker in the main house must be sized appropriately for the total load of the stable. It's recommended to consider a 40 amp or 50 amp breaker, but the exact size will depend on the anticipated electrical demand of the stable. It is also important to obtain an electrical permit for this project. Consulting with a licensed electrician before starting any work is highly recommended to ensure compliance with local codes and safe installation practices. Here are the steps to bond the neutral and equipment grounds. Firstly, install 2 ground rods at least 6 feet apart and driven 8 feet deep. Secondly, connect the neutral and equipment ground wires to the ground rods using approved grounding clamps. Thirdly, install a ground bar in the stable's electrical panel and connect the ground rods to this ground bar. Fourthly, connect all electrical equipment in the stable to the ground bar, ensuring a solid ground connection for all devices. It is crucial to bond the neutral and equipment grounds only at the stable's electrical panel. Bonding them at any other location can create a dangerous situation. When running power to a detached structure such as a stable, treating it as a separate service has specific requirements rooted in electrical safety and code compliance. Firstly, the NEC, which stands for National Electrical Code, dictates that a detached building supplied by a feeder from another building must have a means for disconnecting all ungrounded conductors. This is typically achieved through a main breaker or fuse disconnect located within the stable. Secondly, the grounding electrode system at the stable is critical. As mentioned earlier, it should consist of at least 2 ground rods driven a minimum of 8 feet into the earth and spaced at least 6 feet apart. These ground rods are connected to the grounding electrode conductor, which then connects to the ground bar within the stable's electrical panel. This creates a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock hazards. Thirdly, bonding refers to the connection of all non-current carrying metal parts to the grounding system. This includes metal enclosures, conduit, and equipment frames. Bonding ensures that these metal parts are at the same electrical potential as the ground, minimizing the risk of electric shock if a fault occurs. Within the stable's electrical panel, the neutral conductor, which carries the return current, is bonded to the ground bar. This is the only point where the neutral and ground are connected in a separately derived system, such as the stable's electrical system. Fourthly, the size of the conductors feeding the stable must be adequate to handle the anticipated load. The load calculation should include all lighting, receptacles, and any other electrical equipment that will be used in the stable. The conductor size is determined by the ampacity, or current carrying capacity, required to safely carry the load. Number 3 conductors, as proposed, are a good starting point, but it's essential to verify their ampacity rating against the calculated load. Fifthly, voltage drop is a significant consideration for long runs of conductors. Voltage drop occurs when the voltage at the end of the conductor run is lower than the voltage at the source due to the resistance of the wire. Excessive voltage drop can cause equipment to malfunction and can also damage electrical components. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Using larger conductors, such as number 3, helps to minimize voltage drop. Sixthly, Overcurrent protection, such as circuit breakers or fuses, is essential to protect the conductors and equipment from overloads and short circuits. The size of the overcurrent device should be matched to the ampacity of the conductors. For example, if number 3 conductors are used, it should be protected by a circuit breaker or fuse that is rated no higher than their ampacity. Seventhly, the type of wiring method used is also important. Schedule 80 PVC conduit is a common choice for underground installations as it provides physical protection and is resistant to corrosion. The conduit should be buried at the appropriate depth, as specified by the NEC, to prevent damage from digging or other activities. Eighthly, ground fault circuit interrupters, or GFCIs, are required for receptacles located in damp or wet locations, such as those in a stable. GFCIs protect against electric shock by monitoring the current flowing through the circuit and tripping if there is a difference of more than a few milliamperes between the outgoing and return currents. Ninthly, surge protection is recommended to protect sensitive electronic equipment from voltage surges caused by lightning or other events. Surge protective devices, or SPDs, can be installed at the main panel or at individual equipment locations. Tenthly, proper labeling and documentation are essential for the safe and efficient operation of the electrical system. All circuits should be clearly labeled at the panel, and a wiring diagram should be kept on file for future reference. The process of installing electrical wiring to a detached stable and treating it as a main service requires careful planning, attention to detail, and adherence to the National Electrical Code, or NEC. It is highly recommended to consult with a licensed electrician to ensure that the installation meets all applicable codes and safety standards. Remember that even seemingly small errors in electrical work can have serious consequences, including fire, electric shock, and equipment damage. Here's a more detailed breakdown of the grounding and bonding procedures. Firstly, understanding the purpose of grounding and bonding is crucial. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent device and preventing electrical shock. Bonding ensures that all metal parts are at the same electrical potential, minimizing the risk of electric shock. Secondly, the grounding electrode system typically consists of 2 or more ground rods driven into the earth. The NEC requires that the ground rods be at least 8 feet long and spaced at least 6 feet apart. The ground rods should be driven into the earth until only a few inches are exposed. Thirdly, the grounding electrode conductor, or GEC, connects the ground rods to the ground bar in the electrical panel. The size of the GEC is determined by the size of the service entrance conductors. The GEC should be made of copper or other approved material and should be protected from physical damage. Fourthly, the main bonding jumper, or MBJ, connects the neutral conductor to the ground bar in the electrical panel. This is the only point where the neutral and ground are connected in a separately derived system. The size of the MBJ is determined by the size of the service entrance conductors. Fifthly, equipment grounding conductors, or EGs, connect the metal enclosures of electrical equipment to the ground bar in the electrical panel. The EGC provide a path for fault current to flow back to the source, tripping the overcurrent device and preventing electrical shock. The EGC should be sized according to the NEC and should be made of copper or other approved material. Sixthly, bonding of metal water pipes, gas pipes, and other metal structures is also required. This is done to ensure that these metal structures are at the same electrical potential as the ground, minimizing the risk of electric shock. Bonding clamps should be used to connect the bonding conductors to the metal structures. Seventhly, ground fault circuit interrupters, or GFCIs, are required for receptacles located in damp or wet locations. GFCIs protect against electric shock by monitoring the current flowing through the circuit and tripping if there is a difference of more than a few milliamperes between the outgoing and return current. Eighthly, arc fault circuit interrupters, or FSIs, are required for branch circuits that supply receptacles in dwelling units. FSIs protect against fires caused by arcing faults, which can occur when wires are damaged or insulation is worn. Ninthly, surge protective devices, or SPDs, are recommended to protect sensitive electronic equipment from voltage surges caused by lightning or other events. SPD can be installed at the main panel or at individual equipment locations. Tenthly, proper labeling and documentation are essential for the safe and efficient operation of the electrical system. All circuits should be clearly labeled at the panel, and a wiring diagram should be kept on file for future reference. When dealing with electrical systems, precision and accuracy are paramount. Any deviation from established codes and best practices can have severe consequences. The NEC serves as the definitive guide for electrical installations, providing detailed requirements for conductor sizing, overcurrent protection, grounding, and bonding. Consulting the NEC and adhering to its guidelines is essential for ensuring a safe and reliable electrical system. Licensed electricians undergo rigorous training and possess the expertise to interpret and apply the NEC correctly. Their knowledge and experience are invaluable in ensuring that electrical installations meet all applicable codes and safety standards. Attempting to perform electrical work without proper training and knowledge can be dangerous and can result in serious injury or property damage. Electrical inspections are conducted by qualified inspectors to verify that electrical installations meet the requirements of the NEC and other applicable codes. Inspections help to identify potential hazards and ensure that the electrical system is safe and reliable. Obtaining an electrical permit is typically required before starting any electrical work. The permit process ensures that the work will be inspected and that it meets all applicable codes and standards. Ignoring the permit requirements can result in fines and delays. The choice of materials is also critical in electrical installations. Conductors, conduits, and other electrical components must be of high quality and must be approved for the intended use. Using substandard materials can compromise the safety and reliability of the electrical system. Proper installation techniques are essential for ensuring that electrical components function correctly and safely. This includes making secure connections, protecting conductors from physical damage, and ensuring that equipment is properly grounded and bonded. Working on live electrical circuits is extremely dangerous and should be avoided whenever possible. If it is necessary to work on a live circuit, proper safety precautions must be taken, including wearing appropriate personal protective equipment, such as insulated gloves and eye protection. De-energizing the circuit is always the safest option. Lockout/tagout procedures should be followed to ensure that the circuit remains de-energized while work is being performed. Regular maintenance of the electrical system is important for ensuring its continued safety and reliability. This includes inspecting wiring, tightening connections, and replacing worn or damaged components. Over time, electrical components can degrade due to heat, moisture, and other environmental factors. Replacing these components before they fail can prevent costly repairs and potential hazards. Keeping the electrical panel clean and free of obstructions is also important. Dust, dirt, and other debris can accumulate in the panel and can cause overheating and other problems. The panel should be accessible and should not be used for storage. Electrical fires can be caused by a variety of factors, including faulty wiring, overloaded circuits, and damaged equipment. Having a working smoke detector in the stable is essential for providing early warning of a fire. Fire extinguishers should also be readily available and should be appropriate for extinguishing electrical fires. In the event of an electrical emergency, it is important to know how to shut off the power to the stable. The main breaker or fuse disconnect should be clearly labeled and easily accessible. Everyone who uses the stable should know where the disconnect is located and how to operate it. When planning the electrical system for the stable, it is important to consider the future needs of the building. Adding extra circuits and capacity can prevent the need for costly upgrades later on. It is also important to choose energy-efficient lighting and appliances to minimize energy consumption and reduce operating costs. Solar panels and other renewable energy sources can also be considered. These can provide a sustainable source of power for the stable and can reduce reliance on the electrical grid. When installing solar panels, it is important to follow all applicable codes and safety standards. The installation should be performed by a qualified solar installer. Batteries can also be used to store energy generated by solar panels. This allows the stable to continue operating during power outages. Batteries must be properly sized and installed to ensure safe and reliable operation. Generators can also be used to provide backup power during power outages. Generators should be properly sized and installed to meet the electrical needs of the stable. It is important to follow all safety precautions when operating a generator, including ensuring that it is properly grounded and ventilated. In addition to the electrical system, it is also important to consider the other systems in the stable, such as the water system and the ventilation system. These systems should be designed and installed to meet the needs of the animals and the occupants of the building. Proper ventilation is essential for maintaining air quality and preventing the buildup of moisture. The ventilation system should be designed to provide adequate air circulation without creating drafts. The water system should be designed to provide a reliable source of clean water for the animals. The water pipes should be protected from freezing. The electrical system in a stable is a complex and critical system that requires careful planning, installation, and maintenance. By following all applicable codes and safety standards, it is possible to create a safe and reliable electrical system that meets the needs of the animals and the occupants of the building. In addition to the technical aspects of wiring a stable, it's also important to consider the practical aspects of using the space. The placement of lights and receptacles should be carefully planned to ensure that they are conveniently located and provide adequate illumination and power for all activities. Lighting should be bright enough to allow for safe and efficient work, but it should also be energy efficient to minimize operating costs. LED lighting is a good choice for stables as it is energy efficient, long-lasting, and provides good illumination. Receptacles should be placed near work areas and equipment to provide convenient access to power. Ground fault circuit interrupters, or GFCIs, should be used for all receptacles in damp or wet locations. The wiring in the stable should be protected from physical damage. Conduits should be used to protect wires that are exposed to the elements or to potential damage from animals or equipment. The electrical panel should be located in a dry, accessible location. The panel should be clearly labeled and should be easy to access in the event of an emergency. Regular inspections of the electrical system should be conducted to identify and correct any potential problems. Worn or damaged wiring should be replaced immediately. Loose connections should be tightened. Overloaded circuits should be corrected. By following these simple steps, it is possible to ensure that the electrical system in a stable is safe, reliable, and efficient. It is always recommended to consult with a licensed electrician for any electrical work, especially when dealing with potentially hazardous environments such as stables. Their expertise and knowledge can help ensure that the job is done correctly and safely, minimizing the risk of accidents and injuries. Furthermore, understanding local regulations and codes is essential. These regulations may vary depending on the location and may impose additional requirements beyond the National Electrical Code, or NEC. A licensed electrician will be familiar with these local regulations and can ensure that the electrical installation complies with all applicable requirements. In conclusion, wiring a stable and treating it as a main service involves a comprehensive understanding of electrical principles, safety codes, and practical considerations. By carefully planning the electrical system, using high-quality materials, following proper installation techniques, and consulting with a licensed electrician, it is possible to create a safe, reliable, and efficient electrical system that meets the needs of the stable and its occupants.